In this video, section 2, we're going to go ahead and talk about the trigonometric functions. This will transcend everything we do, especially later on in the higher math courses you got to take and everything. You're using trig identities and trig functions all the time. So what I'm going to do is write down the definition of the trig function first. I'm going to write them out, and then we're going to see how we use them. I am back, and let's go ahead. Let's define this. We're going to let x comma y be an ordered pair, or be any point other than the origin on the terminal side of the angle theta in standard position. So that's what we have right here. And we're going to let r be the distance between the origin and the given point itself. So that is going to be right here. Oh, sorry. Let me get up my highlighter. That's going to be right here. All right. So the idea behind this, all right, is we're going to be looking at like the viewpoint of the angle itself. So an easy way to kind of think about this, and this is the way I always thought about it, is theta is kind of like the head of a stick figure, and this is where you are currently standing. So like, for example, y, the side y right here, will be the opposite. Okay, it'll be opposite of the angle. The letter x right here, well, that's going to be the adjacent side. And I call that the adjacent side because even though r is directly above you, we always call this our hypotenuse side. Okay? So why am I saying this stuff? Well, because we have all of our trig functions right here listed. All right? So for example, sine theta. So that's how we read this. Sine theta is going to be equal to y over r. Now, another way that some people kind of teach this here, and I want to move these over here a little bit. Another way to think about this here is that sine theta is really opposite over hypotenuse. Okay? So it's the opposite side, y, divided by the hypotenuse, r. Cosine is x over r, or another way to think about this would be adjacent over hypotenuse. And tangent, which is the very last one in that row, is going to be y over x, or opposite over adjacent. Okay? And that's because, once again, if we think about ourselves being at that angle theta, we can see how all these sides are related to each other. Now, in purple, let me see if I can go back to purple here. So in purple, we have the reciprocals of each one of these angles as well. So like if you have sine theta, we know that's going to be y over r. Then its reciprocal is called cosecant theta. So cosecant theta is equal to r over y, or hypotenuse over opposite. Then the reciprocal of cosine theta is secant theta. So that's going to be r over x, or hypotenuse over adjacent. And finally, the reciprocal of tangent theta, which is opposite over adjacent, well, that's going to be cotangent. And cotangent, x over y, or adjacent over opposite. And these are the 6 trigonometric functions that we're going to be using. Now, the best part about these trig functions, they apply to all triangles. All right, they apply to all triangles. Okay? However, we're going to focus on the nice ones that all the angles are going to be in between 0 and 90 degrees. So the picture I have drawn here is basically what we're going to be focused on. Okay? Now, the last thing I want to talk about here is the distance r from the origin to the point is always a positive number. And it's called the radius vector. All right? So if you think about what those two words mean. First, I'm going to go over vector. Vector just has a position and a location or a direction. Okay, so it has a position and a direction. That's a vector. Radius, well, think about it. Radius is in a circle, right? And that is what we really are going to be using here, because we're going to build what we call later on, and it's going to be at the end of this section here. We're going to build a unit circle. And we do that by using the ratios of all the trig functions and what we call a unit rectangle, or I'm sorry, a unit triangle, which I'll go over that in a little bit. It's very simple. But let's go ahead and let's just kind of evaluate some trig functions, okay? To help us evaluate trig functions, we're going to use a very famous theorem. And that theorem is the Pythagorean theorem. So remember, a squared plus b squared equals c squared. This is our Pythagorean theorem. So the most famous example, and your book even has this, and this is how we always introduce this, is using a 3, 4, 5 right triangle. So what we want to do is find the values. Oops. Of the 6 trig functions using the triangle below. All right. So here's our triangle right here. I'm going to put theta down here in the corner. And we're going to go 3 and 4 for our legs. Now, the reason why we use the Pythagorean theorem so much is because if you look at this, we have a right triangle here, and we can always find the hypotenuse or one of the legs, if we have the hypotenuse, by using the Pythagorean theorem. So 3 squared plus 4 squared equals r squared. Well, we know 3 squared and 4 squared, well, that's going to be 9 plus 16, which is 25. And then taking the square root of both sides will give us the hypotenuse side, which is equal to 5. All right? And anytime you have a right triangle where all the sides are whole numbers, we call that a Pythagorean triple, because they're very nice numbers. But all we want to do here, all right, is we just want to go ahead and we want to label everything, right? So in this case, we got the distance. Let's see here. So opposite is going to be, oops. Make this a little bit bigger there. There we go. So this is our opposite. This is going to be our adjacent. And now, if we wanted to, we can go ahead and start building all of our trig functions. For example, sine theta is opposite over hypotenuse. Another way to think about that would be so this will be 3 over 5 for sine theta. Now, I'm just going to kind of zoom out here a little bit. We're just going to blast right through these. Cosine theta equals, well, remember, cosine is adjacent over hypotenuse, and then tangent theta is opposite over adjacent. So here we go. Here's our 3 trig identities. Let's get the other 3 now, but we know the other 3 are just reciprocals of this. So, oops, let me make that marker a little bit bigger here. So cosecant theta is going to be 5 over 3. Secant theta is going to be 5 over 4. And cotangent theta is going to be 4 over 3. So now what I'd like to do is talk about the unit circle. So I'm going to go ahead and just write down the definition here real quick, and then I'll show you a big picture of it. We'll show you how to get some of these values, and then we'll call it a day. Okay, so the circle that is centered at the origin and has a radius of 1 is called the unit circle. All right, so real fast, here's what we're looking at. Oh my gosh, that is the most embarrassing circle I think I've ever drew. Let me try this again. Oh, hopefully you're all laughing over there on that side of the screen, because I know if it were me, I would be laughing. All right, let's try this one again. Instead of me trying to get all fancy with it, but I just do this. Yeah, it looks a lot better. Now, if this radius is a 1, then we call this a unit circle. All right. Now, there are all different angles that we have measured on this unit circle. And what I'm going to do is I'm going to show you what they look like. All right. And initially, it's going to look a little crazy at first, but once you see it, it's actually very simple. First thing I want to do is I want to go ahead and I want to define, what do the points on this unit circle look like? So here, what we're going to do is we're going to let sine theta equal y, cosine theta equal x. That means tangent theta is going to be y over x. That means each ordered pair is going to have the form cosine theta, comma, sine theta. All right. And if you look at this in terms of a right triangle, then you have an identity. In fact, this is later on in the semester, but I might as well just show you right now. By using the Pythagorean theorem, and maybe you heard this before, all right? You have the Pythagorean theorem, but instead of using x squared plus y squared equals z squared, or r squared, or a squared plus b squared equals c squared, we have cosine squared theta plus sine squared theta is equal to 1. And this is what we call a Pythagorean identity. And like I said, there will be more about this later. Pythagorean identity. All right. Now, the unit circle that I am referring to looks like this. And here it is right here. So we'll zoom out a little bit so we can get everything on the screen. So first and foremost, okay. Well, let me get a different color out. Got a nice one here. We'll get this light blue and we'll make it larger. So the radius is 1, all right, because that is the ordered pair 1, 0. So we know no matter where on this circle, the radius is always going to be 1. However, what we have here are all the different measurements. So for example, if we have a 30-degree angle, 30 degrees is the same thing as pi over 6. If you were to convert 30 degrees into radians, it would be pi over 6 radians, okay? And the coordinates for that would be the square root of 3 over 2, comma, 1/2. In other words, and this is the way I want to look at it here, is, oops, a little too thick, cosine theta, or better yet, cosine of 30 degrees, which is equal to the cosine of pi over 6, is equal to square root of 3 over 2. And I'll show you how we get these in a different section, okay? Just for now, understand cosine of pi over 6 is square root of 3 over 2. Same thing with sine of pi over 6. The sine of pi over 6 is equal to 1/2. So these are all the different identities that we have, and you can get them all. If we want the tangent of pi over 6, well, remember, tangent is y over x, all right? So it's going to be 1/2 over the square root of 3 over 2, which is equal to 1/2 times 2 over root 3. The 2's reduce. So the tangent is 1 over the square root of 3, or a lot of people want you to rationalize the denominator. So you would get square root of 3 over 3. And that would be the tangent of pi over 6. And then if you think about it, you can get all your other identities too, cosecant, secant, and cotangent, by taking the reciprocal of all these. Now, this does beg the question, which is, do we have any angles we have to worry about? And the answer to that is absolutely. For example, let me erase some of this stuff. There's two that we really got to worry about. And they're right here. Let's make this bigger. It's a 90-degree angle. Now, the cosine of 90 degrees is equal to 0. The sine of 90 degrees is equal to 1. And yes, you could take your calculator. If it's in degrees, you can type that in, and that's exactly what it's going to tell you. But here's the problem. Tangent, all right, remember, is sine over cosine. So tangent is sine theta over cosine theta, which is y over x, okay? And what you have to be worried about here is that is 1 divided by 0, and that's undefined. So we got to worry about 90 degrees, and then the other one we have to worry about, oops, wrong color. The other one we worry about is down here, which is 270 degrees. Because once again, you have that cosine is equal to 0 there. So you're going to be careful with these. But more on that in another video. See you in the next one.